For decades, when we've thought about space travel, we picture this sterile, metallic world, right? Just humans and machines against the blackness of space. But what if I told you we've been leaving our most ancient and maybe most important partners behind? Today, we're diving into a concept that could completely change how we live in space, not by building better machines, but by bringing along our oldest crewmates, microbes.
So here's the massive paradox that's popping up in long-duration spaceflight. We have built these incredible habitats, like the International Space Station, to be the cleanest places imaginable. I mean, think hospital operating room clean. But it turns out that this extreme sterility, this complete lack of biological life, is actually creating a ton of unexpected health problems for the very astronauts it's supposed to protect. And the problem really comes down to this really stark contrast. Here on Earth, we are swimming in a rich, diverse soup of microbes that actually protects us and keeps our immune systems in shape. But recent studies of the ISS show its environment is the polar opposite. It's got very low diversity, it's mostly dominated by the astronauts' own skin microbes, and it's full of disinfectant residues. It's just a sterile and, frankly, stressful place for human body to be.
And this isn't just theoretical. It has very real consequences. Astronauts are reporting things like strange rashes and new allergies. Their immune systems are getting all out of whack. And maybe the most shocking find of all, research has found that their hemopoietic stem cells, the factory that makes all our blood and immune cells, are showing signs of accelerated aging after just 1 month in space. It's like our bodies are expecting this constant conversation with microbes that just isn't happening up there.
So, what do we do about this? Well, the answer might not be more chemicals or bigger filters. It might be something way more elegant. A living system that's designed to fly right alongside the crew. Let's take a look at this concept called the bio-copilot. The whole idea is to repair astronauts with their microbial partners for the long haul. This quote right here gets to the absolute heart of it. We aren't just single organisms. We're walking ecosystems. We're meta-organisms. So if you take away the environmental half of that partnership, we become, as the researchers put it, physiologically incomplete. To be healthy in space, we literally need to bring our ecosystem with us.
And that brings us to the bio-copilot concept itself. The easiest way to think about it, it's kind of like a probiotic for your spaceship. And it's not about just popping a pill. It's a fully contained, engineered system that brings back a healthy, Earth-like microbial environment to support not just the crew's gut, but their skin, their airways, and even the air they're breathing.
Okay, so let's get into how this actually works. The bio-copilot isn't just one single gadget. It's designed to be a whole toolkit, a collection of modules where different groups of microbes are put to work doing different jobs, all working together to make the habitat a healthier place to live.
So the system is built around 3 core modules. You've got the HMM, which they call the health pack, that's for the astronauts' personal health. Then there's the BAM, or the living lungs, which cleans the air. And finally the BPM, the power plant, which is an optional add-on that can generate a little bit of electricity from waste.
The Health Microbiome module, the HMM, is really the foundation of the whole thing. It's the most direct part of the system. We're talking about clinically tested probiotics and prebiotics for gut health, plus things like special pH-balanced skincare. This module by itself is what they call the minimal viable stack. It's the first and most critical piece they want to test out.
Now the BioAir module, or BAM, is where things get really clever. It's a 2-stage system. First, you have a photobioreactor that's just full of algae, and it does what algae does best. It breathes in CO2 and breathes out fresh oxygen. Then, the air goes through a biofilter that's packed with special bacteria that literally eat harmful airborne chemicals, things called VOCs. It's a biological helper for the station's mechanical life support.
And then you have the biopower module. Now, let's be clear, this is not about powering the entire space station. It's a cool little optional extra that uses microbes that eat waste to generate a tiny amount of electricity, just enough to trickle charge some sensors or beacons, making the whole system a little more self-sufficient.
So, we've talked about health, air, and even a little bit of power, but the bio-copilot concept has one more trick up its sleeve. And this is where it goes from just life support and is something that feels like it's straight out of science fiction, using microbes as tiny, living construction workers.
No, I'm serious. This is probably the most mind-bending part of the whole idea. There's an optional 4th module, the biofab module, that is literally designed to turn microbes into on-demand manufacturers.
So how on earth does that work? Well, it's pretty incredible. First, you 3D print a loose scaffold into the shape you want, maybe out of something like Martian dust. Then, you seed it with very specific bacteria, And finally, you just feed it a nutrient solution. The microbes get to work, and their metabolism creates calcite, which is a natural cement, and it binds all those loose particles together into a solid, hard brick. You are literally growing your building materials.
And the potential uses for this are just amazing. You could grow bricks for habitats, you could grow mycelium fungus mats for insulation, or even photosynthetic tiles that help clean the air. But the real game changer? That might be the BioSeal patch. Imagine a living, self-healing patch that you could slap over a tiny crack in the habitat wall. The microbes inside would activate and mineralize, sealing the leak from the inside out. I mean, that's a revolutionary way to think about safety and repair in space.
Okay, so this all sounds absolutely incredible, but I know what you're thinking. It also sounds kind of risky, right? How do you actually get a complex biological system like this approved for spaceflight? The answer is you do it very, very carefully. The BioCopilot plan includes a super detailed roadmap to prove it's safe and effective every single step of the way.
To be perfectly clear, this isn't about letting microbes run wild inside the spaceship. Safety is absolutely the #1 priority. The entire system is built on a strict no-release policy, using what's called a four-walls containment strategy. We're talking double-walled vessels, constant air filtering, pressure monitors, and even automated UV and chemical kill switches if anything were to go wrong. It's basically a biological fortress.
And the development plan is just as careful. It's all broken down into phases. Phase 0 just tests the health module here on Earth. Phase 1 will integrate all the modules for ground testing. Only after all of that works would a completely sealed version fly as a tech demo on the ISS in Phase 2. And that would eventually lead to a full pilot program on a future habitat, maybe like the Lunar Gateway. It is a step-by-step, safety-first plan.
And this isn't just wishful thinking. This is real, hardcore engineering. The project has set very clear, very measurable goals for each phase. For example, in the ground tests, the air filter has to reduce target chemicals by at least 20%. The algae have to hit a specific CO2 absorption rate. And those biobricks? They have to achieve a compressive strength of at least 5 to 10 megapascals. Just to give you an idea, that's in the same ballpark as residential concrete.
Which really brings us to this final, pretty mind-blowing thought. For all of human history, we have built our shelters. But concepts like BioCopilot suggest a radically different future for us as we move out into the solar system. It really makes you wonder and asks this profound question about our future off-world. Will our first homes on Mars be assembled from parts we ship from Earth, or will they be grown, living structures created in partnership with our oldest biological allies?